In this video, we will be seeing the shape of XeF2. Now, whenever we discuss the shape of XeF2 based on the previous video regarding the hybridization of XeF2, we predicted that it is trigonal pyramidal geometry. Of course, it is having a trigonal bipyramidal geometry. Sorry, it is not trigonal pyramidal, trigonal bipyramidal geometry, but here the way sometimes the competitive questions will be asked with respect to certain figures. See, three possible arrangements are there with respect to this trigonal bipyramidal. As we discussed these arrangements where the lone pair of electrons are available in these molecules. First arrangement can be like this. So, if we take these three spots as the three corners of equilateral triangle, we can have one lone pair here, another lone pair here, and another lone pair here. So this can form a beautiful trigonal plane, something like this. And bipyramidal can come like this, one fluorine here and the other fluorine here. So this can be say the first structure. The most important point here is in this structure, three lone pair of electrons are present in the equatorial position. The first arrangement. Second arrangement can be like this. All the three lone pairs need not. So these electrons in the three lone pairs in the equatorial position, as they are not in the axial position, this structure is highly stable. So we can say that this is figure A. Coming to the next structure, you can have xenon here. We can say that say one fluorine can be in the equatorial position. This is one more equatorial position. One lone pair of electrons can come here, and the other lone pair can be in the axial position. One more lone pair also can be in the axial position. Therefore, we can say clearly that this kind of arrangement will give an equatorial position like this, followed by, so this is equatorial, this is equatorial, this is equatorial, this is axial, this is axial. Similarly, this is axial, this is axial, this is equatorial, equatorial, equatorial. Now, if you see in this case here very clearly, so two lone pairs are in the axial position and one lone pair is available in the equatorial position. So you can see this is figure B. So figure A, so in this case there will be more lone pair repulsion than arrangement in figure A. Therefore, we can say figure A is more stable than figure B. This is more highly stable. This is so I'll write it very clearly here. This is figure A. So this is less stable. We can say that figure B is particular figure B is least stable. Okay, we can say that this is least stable. Now, in between these two structures, there is one more small arrangement, stable arrangement. So this will be figure C. If there can be a structure like proposed like this, a shape of the molecule where two lone pairs could be in the equatorial position and one lone pair in the axial position. So this is equatorial, this is equatorial, this is axial. So this one fluorine once again in the axial and this fluorine in the equatorial. Now see, in this case what happens is very clearly, two lone pairs are at least in the equatorial, whereas in figure B if you see, two lone pairs are in the axial. So this is figure C. Therefore, we can say clearly that the stability order follows like this. Figure A will be more stable than figure C. Figure C will be more stable than figure B. So they give option A, option B, option C. Which of the following arrangements are more stable for XeF2, or decreasing or increasing order of XeF2 can be positioned.